Welcome back to All This Math. This is Professor Parker. Make sure you are subscribed to the All This Math YouTube channel. Make sure you like this video. Make sure you drop a comment down below and make sure you share this video with somebody. All right. Also, going over to Amazon, make sure you have a copy, if you don't already, of How to Use All This Math Volume 1. Right? That's my book, resource guide for parents, showing you how to convert everyday activities into teachable moments and math lessons. All right, let's get into this. So what are we doing today? Today we're doing a lesson on what are called piecewise functions. Piecewise functions. All right, and we're going to graph them. We're going to graph this piecewise function. All right. Now, first of all, why is it called a piecewise function? It's called a piecewise function because we're not going to graph the entire function. We're only going to graph a piece of the function, if you will, a piece of it. Just like when you might be hungry, but you're not that hungry. You want a piece of a sandwich or a piece of cake, right? You don't want a whole big piece of cake. You want a small piece of cake, like it's somebody's birthday. Shout out to my nephew Amir. He just turned 13. Well, he turns 13 sometime this week, but they had cake and ice cream for him today down my mom's house. But anyway, shout out to him. But you might want a piece, right? Just a piece. That's what we're gonna do. We're not gonna graph the entire function, right? We're only gonna graph a piece of it. All right. Now the question you should probably have is, how do I know what piece or how big the piece is or where the piece is? This right here. This is called our domain, where it says x is less than 1. That's the domain for this function. F of x is equal to 2, but we only want the part of it where x is less than 1. And then we have another function. So we got two functions at the same time. That's another aspect of piecewise functions. You're going to have multiple functions. You might have two functions, three functions, four, five, six. Most examples you're going to see probably you'll see two functions or three, maybe max, right? Sometimes you might see four, but usually either two or three. And then the second function, we got f of x is equal to x plus 3. But we only want the part where x is greater than 2, right? So think about it like this. This is the domain. The x values are the domain. X is less than 1 and x is greater than 2, right? That's the where, right? So this is the where. So we got where and we got what. So where and what, right? That's what we got. We got where and we got what, right? So now, right? So let's say I wanted to graph this first function, f of x is equal to 2. I don't really like function notation unless I gotta use it. So also you need to understand that f of x and the variable y mean the same thing. F of x and the variable y mean the same thing. So we got y is equal to 2, right? So let's graph this, right? Y is equal to 2. Now, whenever you're graphing a function and you have y equals a number and there's no x variable, just know that it's going to be a horizontal line. Now, you need to understand what the word horizontal and the word vertical means. Horizontal, left to right. Vertical, up and down and up. Vertical, up and down. Horizontal, left and right. So if I'm graphing y equals 2, all I do is I go to find y on the y. I go to find 2, positive 2, not negative 2, 2 on the y-axis. Where is that? Where is 2? Start here at 0 at the origin. I go up positive 1, not to the right or the left, not to the right or the left. This is not the y-axis. This is the x-axis, right? On the y-axis, it says y equals 2 or y is 2. So on the y-axis, I start at 0. I go up to positive 2, and I draw a point right there. I draw my point right there, right? And then, like I already said, if it's y equal to a number, the number could be 2, 10, 9, 8, 4, 400, 672, 381. Like how many days the Montgomery bus boycott lasted back in 1955, right? It could be 381, right? It doesn't matter what the number is. The number could be negative. Number could be big, could be small, could be a fraction, could be a decimal. It doesn't matter. If it's only a number, it's going to be a horizontal line. Make sure you know what the word horizontal means. Horizontal is not diagonal. It's not vertical. It's horizontal, like the x-axis. It's going to be parallel to the x-axis. So what we do is we take our ruler, and we draw a horizontal line through y equals 2. Right? Now, that's what it would normally look like under normal circumstances if there was no domain restriction and we didn't just want a piece of it, right? If we wanted the whole thing, it would look like this. Y equals 2. You got an arrowhead on the left end, an arrowhead on the right end. That's what it would look like if we wanted the whole thing. But we don't want the whole thing. How you know we don't want the whole thing? Because it's a piecewise function. That means we only want a piece of it. I don't want the whole thing. I just want a piece. Just let me get a piece. Let me get a taste. You know what I'm saying? Like I just want a piece, right? So, but where's the piece at? Look at the domain, right? Where x is less than 1. Okay? So I need to find 1 on the x-axis. 1 on the x-axis, positive 1 is right here, right there, right? So I'm saying I want the piece of this function, the piece of the graph that's less than 1. So I'm going to go here and watch what I do. I'm going to put an open circle. I'm going to erase this. And I'm going to put an open circle right here, right? Now, why open circle and why not a shaded in circle? An open circle because it says x is less than 1, not equal to 1. If it was equal to 1, it would be a shaded in circle, but it's less than 1. So I want the piece of the function that is less than, where x's are less than 1. So I want where 0 is. 0 is less than 1. -1 is less than 1. -2 is less. -3, -4, -5, -6, -7, -8, all that. And the arrowhead is still there because it goes on forever to negative infinity. But what am I going to do with this over here? What am I doing with this over here? It's gone. We don't need it. We don't want it. The only reason I drew it in the first place was to prove a point. To show you that under normal circumstances, we would have had the whole, that's what the whole function looks like. But since I just want a piece of the function, it's going to look like this. It's going to be an open circle, not a shaded in circle. Again, an open circle because I want the piece where x is less than 1, not where x is equal to 1. X is not equal to 1. X is less than 1. That's why the 1 is not part of this function, right? Everything less than 1 is. All right. Now that's how we do the first part. Now, I want to graph f of x equals x plus 3. Now, again, I don't want to use function notation. That's just me. You can use function notation if you want to, but I'm going to do y equals x plus 3. And I'm going to graph that. So if y equals x plus 3, right, this is a linear equation. It's in the form y equals mx plus b, right? I know a lot of people talk trash about y equals mx plus b, and they claim that it's irrelevant. I never used it in life. Okay. Let me show my mic is on. Yeah. So yeah, it is relevant. And you do use it in life. You just might not recognize when you're using it. Every time you calculate your paycheck, if you work hourly, you're using y equals mx plus b, whether you like it or not. And it's 10,000 other examples too that I won't get into right now. But anyway, y equals mx plus b or y equals x plus 3 in this case. What is my y-intercept? What is my slope? What is my y-intercept? What is my slope? What is my y-intercept and what is my slope? My y-intercept is this number right here, the 3. The 3 is my y-intercept. What's my slope? My slope is the coefficient of x. Now, there's no number written next to x. So if there's no number written, we know it's, and understand it's a positive 1 whenever there's no number written. So my slope is 1, my y-intercept is 3. My slope is 1, my y-intercept is 3. How do I graph this though? You always start with the y-intercept. You start with the y-intercept, right? That's the point where the line is going to cross the y-axis, right? Think about football, right? If the defensive back is on the y-axis, he's going to intercept the pass from the quarterback. Quarterback is throwing a pass to the wide receiver or to the tight end or whatever. The defensive back is going to intercept it somewhere. This particular defensive back is going to intercept it at positive 3. So here's positive 3, positive 1, positive 2, positive 3. Now I'm drawing it like I'm drawing the whole function, not a piece. At first, I'm drawing the whole thing, and then I'm going to erase what I don't need, right? I'm going to draw the whole thing, then I'm going to erase what I don't need. Some people teach it different. Some people just straight draw just the part that they need, right? And on some videos, I might do that. But this one, on this video, I'm not doing it. I'm not doing it like that. I'm going to draw the whole function, and then I'm going to just erase what I don't need, right? So this is my y-intercept, positive 3, and then my slope is 1. So because my slope is 1, we use the variable m to represent slope. I treat slope like a fraction. So So m is equal to 1 over 1 because 1 can be represented as a fraction, 1 over 1, right? Now, what does that mean? The top number tells you how far to go up and down from the previous point. The bottom number tells you how far to go right or left. So because it's positive 1, we're going to the right. This is positive 1, so we're going up. If it was negative 1 on top, we would go down. If it was negative 1 on the bottom, we would go left, right? So now, what do I do? Because the slope is like a set of directions. That's what the slope is. It's a set of directions. It's not a point. It's a set of directions, a set of instructions. So from this point, we're going to go up 1 space and to the right 1 space. And we only need a minimum of 2 points to draw a line. You need a minimum of 2 points to draw a line, right? So I got my 2 points, my y-intercept and my second point that I got from using my slope. I went up 1 space and to the right 1 space, up 1 space and to the right 1 space, right? So now, check this out. Let me see. All right, so I want to graph this, and my domain is x is greater than 2, right? My domain is x is greater than 2. All right. Oh, my point is a little off. Hold on a second. Because it should be above 1, up 1 and over 1. Yeah, it should be right there like that, right? So now what I'm going to do is, and actually because I'm not going to actually draw the whole function. I'm not, because I don't want to have to erase all of this down here unnecessarily. I know that I only want the piece, see, piecewise, I only want the piece that's greater than 2. So I'm looking at what this line is about to do. This line is about to go up, right? And matter of fact, let me use the slope to find another point, right? Let me go up 1 and over 1 again. Now look at that. That lines up with positive 2, right? So I only want the piece of this function that is to the right of positive 2, where the x's are greater than 2. Again, let me say that again. I only want the piece of this function where x is greater than 2. X is 1 right here. X is 2 right here. So I don't want nothing to the left of here, right? And actually, look at what happens. Because x is not equal to 2, x is greater than 2, I'm going to put an open circle, just like I had right here. I got another open circle. Why open circle? Why is my circle open and not shaded in? Because x, we want the values of x where x is greater than 2, not x is greater than or equal to 2. X is not equal to 2. X is greater than 2. So watch what I do. I'm going to draw my line. From this point, and I'm going to put my arrowhead on the end, shade it in, and then let me erase these points because this point don't need to be here, and this point don't need to be here. So look at that. Let me fix my graph a little bit. I'm just very particular about how my graph looks. All right, so look what we got here. All right, our pieces. We got 2 pieces. 1 piece, 2 pieces. 1 piece, 2 pieces. Our first piece is, this is f of x is equal to 2, but only where x is less than 1. Because look, that's 1. This the x-axis. This is 1. That's why didn't I draw nothing over here? Because it says x got to be less than 1. So why would I draw it where x is 2, or where x is 3, or 4, or 5, or 6, or 7, or 8, or 8.5? None of those numbers are less than 1. None of those numbers are less than 1. So why would I draw the piece where it doesn't follow the directions? See, every time you see something in math, it's like every problem is like a set of directions, right? Math teaches you how to follow directions. Just follow directions. That's all you got to do. Just follow directions, right? Now, this piece is a piece of f of x equals x plus 3. But I only want the part where x is greater than 2, right? So look, here we go. This is 2. It's an open circle because x ain't equal to 2. X is greater than 2. So we put the open circle at 2, and then everything beyond it, every point that's got an x value greater than 2. My x value is 3 right here. X value is 4. X value is 5. X value is 6. X value is 7, right? on and on and on and on forever. This is going to go on forever past the Asada Shakur picture all the way up there, right? And that's what we got. So this is how we graph the piecewise function. All right. So we got two. We started out with two functions. F of x is equal to 2, and f of x is equal to x plus 3. And we graphed a piece of each of those functions. All right. A piece of each of those functions. All right. So remember, like I said, make sure you subscribe to the channel. Make sure you like this video. Make sure you drop a comment down below. Make sure you share this video with somebody else. Also, make sure you have a copy of How to Use All This Math Volume 1, an excellent resource for parents that want to prepare their children for math class. I'll see you all in the next video.